The year was 1993, when Swiss physics student Urban Müller designed the Brainfuck programming language. His goal was to test the limits of programming by designing a language that would work with the smallest possible compiler. His inspiration came from the false programming language, which had a compiler as small as 1024 bytes. And good old Urban managed to reduce this size to 296 bytes in his first version of the compiler. Although nowadays the community has already designed compilers of the Brainfuck language of less than 200 bytes. This language, halfway between a work of art and a mind game, is of little practical use, as programs are very difficult to write and even to understand. This is partly because any complex task requires a long sequence of commands, and partly also because the code does not give direct indications of the program's status. Despite this, and although it sounds crazy, it's a Turing-complete language, which means that technically any computational problem can be solved with it. That is, only if it is given access to an unlimited amount of memory, which is no small request. The language is based on a simple execution model consisting of 4 elements. First, we have the program to be executed. The second element is a vector of at least 30,000 bytes, all of them initialized to 0. The third element is a pointer on this vector, which at the beginning of the execution points to the first element. And finally, we have 2 byte streams, one for the input and one for the output. A Brainfuck program consists of operation on the pointer that we have defined previously, and we can operate on this pointer with a total of 8 commands. Imagine that we have a vector of cell containing certain values. With the greater than and smaller than symbols, we can move the pointer to the left or to the right. To change the value of a cell, we can use the plus to increase the value or the minus to decrease it. With the square brackets, we can create a loop which will repeat until the current value of the cell is 0. And finally, we can use the dot to generate the byte at the current location of the pointer, or use a comma to accept an input and store it at the current location. Notice that we don't have any of the elements that we are used to in high-level languages, such as variables, functions, or classes, because, well, that would make everything too easy. To create a Brainfuck program, we can create a file ending in .b. Any character that I have not mentioned previously will be ignored as a comment. At this starting point, we have an array with 30,000 8-bit numbers all set to 0. Let's create a program to add 2 numbers, say for example 3 and 5. The pointer starts pointing to the first position of the array in memory, so we can put there a 3 with 3 @ symbols. In the next cell, we can place the 5. Now we are going to program a loop, where we will be decrementing the value of C1 and incrementing the value of C0, until the value of C1 is 0. We start the loop by opening square brackets. We move to the first cell and increment the value by 1. Now we go to the cell C1 and decrement the value also by 1. And now we close the loop. This loop will repeat until the value of cell C1 is 0. And then the value of C0 will be 8. So we have finished our program to add 2 numbers. If we now want to display this value on the terminal, we cannot do it yet, because we would have to transform it into an ASCII character. To display the letter 8 in ASCII, we have to add 48 to the number 8, which we can do by multiplying 8 by 6, for which we can put an 8 in the second cell. And for each cycle of the loop, we will increment by 6 the value of cell C0. To run the code we have written, we can copy the program and paste it into one of the many online interpreters. Congratulations, you have just made your first program and you are ready to start your career as a Brainfuck developer. If you want to see more content like this, don't forget to like and subscribe to the channel, and I'll see you in the next video.